This is section 4 of chapter 10, inferences and hypothesis testing about two population proportions. So now we have binary data, two columns of binary data. Let's start with some notations. So we have the first population, and P sub 1 is the proportion of successes in the first population. So it's either success or failure binary data. And the second population, the same success, the proportion is P sub 2. So we have P sub 1 from population 1, P sub 2 from population 2. So our parameter of interest is what is the difference in the two proportions. Oftentimes we want to see whether the difference is 0 or not, or greater than 0 or not, things like that, whether the two population proportion successes are equal. For example, in an opinion survey, so how many people like a particular product, say male versus female, whether the proportions are same or not. So the difference in the population proportions is the parameter of interest. So to estimate the difference, we take a sample from the first population and a second sample from the second population. The two samples must be random samples and they must be independent of one another. N sub 1 is the sample size of the first sample, N sub 2 is the sample size for the second sample. Then we calculate the proportion of successes in the first sample, and the notation is P bar sub 1. And P bar sub 2 is the proportion of successes in the second sample. Now if we take the difference between the two sample proportions, that is our point estimate for the parameter of interest. So our estimate for P sub 1 minus P sub 2 is P bar sub 1 minus P bar sub 2. And it so happens that the expected value of the sample difference is equal to the population parameter differences. So now we have to compute the standard error. Standard error for our point estimate, P bar sub 1 minus P bar sub 2, is given by this formula. So that's sigma sub P sub 1 minus P sub 2. Now you notice that this formula requires the value of P sub 1 and P sub 2, which are unknown. So this has to be estimated. So the estimated standard error is you replace P sub 1 with P sub 1 bar, you replace P sub 2 with P sub 2 bar. Then you get an estimate of the standard error. And now we are ready to construct a confidence interval, and we want to be able to use the normal distribution for this. And in order for us to be able to use the normal distribution, we need to make sure that the sample sizes are large. And therefore, we need to make sure that these factors are all greater than or equal to 5. So you take the first sample, N sub 1 times P sub 1 and N sub 1 times P sub 2, they both must be greater than or equal to 5. The same must be true for the second sample, N sub 2 times P sub 2 and N sub 2 times 1 minus P sub 2, both must be greater than or equal to 5. Then both samples are large enough, and once both samples are large enough, then we can use this formula to figure out our confidence interval for P sub 1 minus P sub 2. So we are now able to use Z table because the samples are large, and then we use the estimated standard error. So this is our point estimate, and that's our margin of error. Now the next topic is hypothesis testing, and once again hypothesis testing has three different formats, and the parameter of interest is P sub 1 minus P sub 2. So we can have one of the two possible one-tail tests or the two-tail test. Now you notice that in all of these three different forms, the null hypothesis includes the case where P sub 1 minus p sub 2 equal to 0. In other words, the case that p sub 1 and p sub 2 are equal to some common value is part of the null hypothesis in all the three formats. So that allows us to pool the two samples, and this will give us a more accurate estimate of the standard error. So we combine the two samples and then come up with a combined pooled estimate. We call that p bar. It's a pooled estimate between p sub 1 and p sub 2. And with the pooled estimate, then we can calculate the estimated standard error in this way. Okay, so there is a difference here. In confidence interval, that is your standard error, whereas for hypothesis testing, the standard error is slightly different. We use the pooled estimate for the probability of success. We can use this in our z statistic. So the z calculated value is given by this formula, and once we have the calculated test statistic value, we can use the norm.dist function to calculate the p-value. So the first one is for the one-tailed test, the second one is for the two-tailed test. So once we have the p-value, then we can make a conclusion.